Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at the proof for the cosine rule. Now, in this section of trigonometry, we are working with non-right angled triangles. Now, when it comes to working with the non-right angle triangles, our normal trig ratios would not apply, and hence the cosine rule is one of the rules that we use in order to solve these triangles. Proving this is extremely important as it would allow you to understand where this rule comes from and how to apply it correctly. So stick with me and we are going to work with this. Now, in order to prove that the cosine rule is a law that applies to non-right angled triangles, and in order to use it effectively, we have to complete the proof. So what we have on screen here is a simple non-right angled triangle. This is a triangle of which its angle does not consist of 90 degrees. What I've done is I've labeled them accordingly, where the side opposite the corresponding angle has the small letter corresponding to the capital letter at the angle. Understood? So where angle A is, opposite it would be the side small a. Where angle C is, opposite it would be the side small c. And where angle B is, opposite angle B would be the side small b. What I've also done is I've put the cosine rule on the screen for you guys to have a look at. Now what we're going to do is I want you guys to identify something really important and really special when it comes to this rule. And that is this portion of the equation right here. From c squared to b squared. What I'm speaking about is c squared is equal to a squared plus b squared. Now this is extremely important. It looks quite familiar, guys. Am I right? This is your theorem of Pythagoras. So essentially what we're saying is the cosine rule is the theorem of Pythagoras minus this entire section over here, which allows us to apply it to a non-right angled triangle. And we're going to prove this rule and show you guys how it works. Now, when it comes to our basic skills for triangles in mathematics, we usually have these skills that are only applicable to right angled triangles. And the skills that I'm talking about is your basic trigonometry, sine, cos, tan, and your theorem of Pythagoras. But now we see we have a non-right angled triangle, and we are going to have some sort of difficulty proving that with the mathematics that we have available to us at the moment. A simple solution to this would be to construct a line perpendicular to one side of the triangle from a corner perpendicular to one side of the triangle. And what we've done is we've created two right angled triangles from this one non-right angled triangle. Can you guys see that? And this can be done for any and all triangles. If you take any triangle, you would be able to create two right angled triangles from it. Okay? So this is going to make our life much easier when it comes to proving the cos rule. What I'm going to do is I'm going to indicate a little label over here because now we are working with two triangles instead of one. Put simply, this would be y, this would be x, and this point over here would be d. I'm going to label that as d. Now, if y is the distance from D to C, naturally, the distance from A to D should be B minus y, because the entire length A to C is in fact B. Now that I have all my variables and all my data inputted, I can now work with this triangle. So what I'm going to do is, instead of working with one big triangle, I'm going to work with each triangle individually, with each of the right angle triangles individually. Okay, so what I've done so far is I have created two new triangles from the original non-right angle triangle, and I've just separated them and redrawn them for us to work with. This is taken directly from the triangle that you can see in the center. It's the exact same values, exact same angles. Now these two right angle triangles allow us to do something extremely special. And that is the fact that theorem of Pythagoras is now applicable to this. And the reason why I'm speaking about theorem of Pythagoras is because of this first part of the formula. It is essentially a theorem of Pythagoras. So that's giving us a little hint at what we need to do in order to prove this rule. So our first step is going to be to use theorem of Pythagoras for both of these triangles. Okay, and we are going to leave the hypotenuse as the subject of the formula in both. In terms of triangle ABD, we can say that the hypotenuse is actually C. So applying theorem of Pythagoras, we will get C squared is equal to x squared plus b minus y squared. Agreed, because that is the value assigned to those sides. If I'm looking at the triangle BDC, I can say that A is my hypotenuse. So applying theorem of Pythagoras, I will get A squared is equal to x squared plus y squared. Now guys, I want you to notice something. The original triangle is triangle ABC. Now that I have inputted some new variables, being x and y, I want to get rid of those because those aren't going to fit quite well in the formula for cosine. That's my entire objective. I want to get rid of it. So what I'm going to do is I'm going to first simplify the triangle on the left, and by doing that I should get x squared is equal to, x squared plus b squared minus 2by. Right. And I've obtained this little expression by foiling or by squaring this entire bracket, right? Now, my entire objective is to, of course, get rid of these new variables that I have inputted in so that I can work with this a bit easier. So what I'm going to do is I'm going to substitute in from this formula into that formula. And what I'm going to substitute for is going to be y squared, because that is something that I do not want. So simply by rearranging this formula over here to make y squared the subject of the formula, I should get y squared is equal to a squared minus x squared. Now what I'm going to do in this case is I'm going to substitute this entire expression into y squared in the second formula. Into y squared in the first formula. So this would now become c squared is equal to x squared plus b squared minus 2by plus a squared minus x squared. I substituted in this part over here for y squared. Now we are going to notice a few things when it comes to this equation right here, and that will be x squared and negative x squared will cancel each other out. Okay, that's the first thing that we're going to notice. The second thing that we're going to notice is now we brought about an a squared in this new formula, and if you use your original formula as a reference, you can see that the correct order is c squared is equal to a squared plus b squared. So all we're going to do is we're going to rewrite this. We're going to say c squared from there is equal to a squared from there plus b squared minus 2by. And we are almost there, guys. So far we can see the entire first part of this question or of this equation has been proved. Has been proven, right? The only thing that we have to worry about now is getting rid of this y over here, because we don't want that y to be there. Now if I am looking at the triangle on the right, the only value that is original, or the only side that is original to the triangle that I had initially, would be a. Both y and x are values that I assigned. So I'm going to solve for y in terms of a. Using my basic trig, I can see that side DC is adjacent to angle C. So I'll label it as adjacent. And I can see that side BC is the hypotenuse of this triangle. Now if I have the adjacent and the hypotenuse of a right angle triangle, I can use the cosine rule in order to show this relationship. And put simply, this would be cos of angle C should equal to adjacent, which is y, over my hypotenuse, which is a. Now I want to get rid of y, guys. I don't want y to be there. So simply all I'm going to do is I'm going to make y the subject of the formula so that I can substitute in for it and get rid of it. So by manipulation, y should equal to a cos c. Now I can take this bit over here and substitute it in for y in this formula. And by substituting a cos c in for y in this formula that I'm working with, I will get c squared is equal to a squared plus b squared minus 2b a cos c. And I can rearrange this over here because multiplication is commutative, meaning I can move its position, and I will obtain the equation c squared is equal to a squared plus b squared minus 2ab cos c. And that is how you prove the cosine formula. All the best, guys, and I will see you in the next one.